talk a little bit about the FLR network. The FLR network is a distributed network whereby nodes run the Avalanche Consensus Protocol with key adaptations to a Federated Byzantine Agreement (FBA) consensus topology. The FLR network leverages the Ethereum virtual machine, enabling the networks to run Turing complete smart contracts. The combined usage of the FBA consensus topology with a Turing complete smart contract layer makes FLR a scalable public smart contract network that does not require a native token for safety. This is a useful property as the cost to attack network safety in networks that do not leverage a token for safety is related to the speculative value of the token, thereby facilitating an incentive in these networks to create a double spend attack whereby the cost of an attack is lower than the reward from the successful double spend. Instead of being used for network safety, FLR's native token, the Spark, is used trustlessly issue tokens from non-Turing complete networks such as XRP onto FLR so that they can be leveraged in Turing complete smart contracts. This trustless issuance on FLR does not require the cooperation of the non-Turing complete networks, meaning that the other networks do not have to make any changes to their protocol to enable the issuance on FLR. The FLR networks can then cooperate with interoperability protocols that do not require bilateral protocol cooperations for cross-network asset issuance, such as Cosmos, meaning that FLR can act as a unique frictionless pipeline of non-Turing complete assets into these networks. Governance over the networks and a wide set of parameters is achieved through Spark token ownership. This allows FLR and its core applications to be highly dynamic, upgradable, and increasing in utility. Now let's go over FLR consensus. The FLR network is organized in an FBA topology for its network level consensus. FBA is unique as consensus topology in that it achieves safety without relying on economic incentives that can interfere with high value, high risk use cases. A criticism of pure FBA is that it leads to fragile structures of constituent nodes, permitting topology scenarios where a single node failure can cause a network-wide failure. A specific setting of FBA called unique node list topology is prioritized that emphasizes clarity and ease of use while maintaining an open membership property of FBA. The basis of the UNL topology is symmetry in network structured by requiring that the set of nodes that each node relies on for economic intersects with other nodes set by a governance-defined threshold called the UNL. Intersection set, which prevents the single node failure mode of the pure FBA topology. The total number of nodes in a UNL is defined as n. Note that the value of n can technically differ between different node operators as it privately set variable that cannot be forcibly set by others. However, for simplicity or safety analysis, it is recommended that nodes agree on a value for n through a non-automated Spark token holder governance vote. Consensus on the state of external systems, such as the XRP ledger or a stock market, for use in applications on FLR, such as FXRP, is a high-risk process. For example, the external system could suddenly issue a signal that $1 billion worth of value has moved. As soon as possible, then and without any human intervention, the FLR network needs to be able to compute the finality of this external state such that it is available as a signal to the downstream applications on FLR. Such as FXRP, in the case of FXRP, if the XRP ledger state were recorded incorrectly to the FLR network, then it would be possible to create $1 billion worth of FXRP on the FLR network that cannot be then converted back to XRP, undermining the value of the issued FXRP and any application that depends on it. Thus, consensus on the state of external systems must be safely organized for immediate use in downstream applications on the FLR network. This is achieved via state connectors, which are responsible for safety encoding the state of external systems to the FLR network. The state connectors are organized in an FBA topology in the UNL symmetric setting, just like the underlying FLARE network nodes. Each state connector is run by a shares the same UNL definition as its FLARE network node. There are three phases of the state connector system. 1. Sampling the external system state. 2. Registering the state on the FLARE network. And 3. Finalizing the state for use in smart contracts on the FLARE network. The state connectors are designed in order to fulfill the following criteria. 1. Open membership in the same way that anyone is permitted to participate in the consensus of the FLARE network. Anyone is also permitted to run a state connector. Consistency. The recorded external state should be consistent between nodes on the FLARE network over time. 3. Independent verification. A state connector should be able to independently verify an external state before it gets finalized to the FLARE network state. That is, if a state connector's independent verification fails, then the state connectors does not permit the proposed external system state to be applied to its local FLARE network node. 4. No reliance on economic incentives for safety. Control over the state connector system should not be based on who has the most money. Although state connectors independently verify the external state such that they only permit the state that matches reality to be applied to the FLARE network. A state connector with enough money could block the overall state connector system from making progress on determining consistency between nodes on each FLARE network over time if control over this system were based on who has the most money. This has the same risk as basing the network consensus on who has the most money. That is that it would fundamentally limit the value that can be expressed in the system. Let's go over the Spark token. The Spark token is the intrinsic currency of the FLARE network. Spark's technical purpose is to impose a cost upon transaction so as to disincentivize superfluous transactions. Example, network spamming. This is achieved via transaction fees. The FLARE network uses the Ethereum virtual machine. The Ethereum virtual machine defined as a transaction computational complexity in terms of units of gas. To avoid extremely lengthy or interminable transactions, FLARE imposes a complexity limit defined in gas units. A gas conversion rate between gas and Spark tokens is set by the network. Thus, a transaction cost is defined as a complexity limit multiplied by the conversion between gas and Spark. The transaction cost is burned rather than accruing to some set of participants. Both the complexity limit and gas to Spark conversion rate are governance parameters. Spark is used as the arbiter of network governance and central component of an interlocking set of utilities that collectively form a novel way of structuring decentralized applications, termed Spark-dependent applications. A Spark-dependent application is an application which can be built utilizing any combination of the following three components. 1. A Spark-mediated time series oracle. 2. Spark used its collateral. And 3. Spark-mediated governance. The SDA structure is intended to provide utility by applying applications that deploy on FLARE to optionally benefit from 1. Access to assets and ecosystems that were not previously available through trustless representations of non-Turing complete assets, as exemplified by FXRP. 2. The value of Spark as collateral or a usage medium. 3. The use of the FLARE time series oracle. 4. The depth of interest and expertise that can be brought to bear over governance questions. The increased likelihood of attention for a new application from the Spark owning community against the attention that applications would have through bootstrapping from zero. The Spark token will be distributed to the XRP ecosystem in what is intended to be a soft fork that generates considerable utility for the original chain XRP by enabling the use of XRP with Turing complete smart contracts instead of trying to compete with it. A more apposite term for the process would be a utility fork. Let's go over FLARE governance. the Spark token is used as a primary governance mechanism over the network. The Spark token and the FLR time series oracle Spark can also be optionally used for governance over dependent applications. Certain updates from governance decisions can be automated, termed automated processes, whereas others, the non-automated processes, cannot. The latter typically requires a more complex procedure requiring for instant changes to the code base. Automated processes that relate to a variable which can take a range of values are designed to increment slowly so as to avoid shocks to the system. An emergency automated process is defined for situations where there is general consensus among Spark owners that the variable under consideration needs to be altered rapidly. Decisions are categorized into whether they relate to the networks and its technical parameters. The Spark token or the FLR time series oracle governance decisions are made through voting using the Spark token. Each Spark token equals one vote because different decisions have different impacts on the network's supermajority and supermajority. Each of these places specific requirements on the number of Spark tokens participating in the voting process, as well as the number of votes for a proposed proposition to pass. The Spark tokens held by the FLR Foundation may not be used to vote and are considered not to exist for the purpose of governance. FLR will follow a liquid democracy model whereby token holders are free to vote themselves or to delegate some or all their tokens votes to another entity which votes on their behalf. A voting entity that amasses delegated votes can be formed by any one or a collection of people. One of those entities will be the FLR Foundation. The FLR Foundation is to be a nonprofit organization whose mandate is to participate in developing and improving the network. The foundation will undertake this in 5 ways: grants, investments, direct software development, education content, and publicity and partnerships. If operating correctly, the foundation should be a rallying point for the ecosystem to communicate, innovate, and further develop. It should not have excessive power in the network, nor should it interrupt or distort any of the economic processes that operate on the network. To that end, the foundation is bound by a set of rules, which include no voting. The FLR Foundation is intended to help enact the collective will of the network. Its role in the governance process is to give opinions and technical analysis over proposals and help implement accepted proposals. The foundation may not use its token holdings to vote at any stage in the governance process. No collateral. Foundation tokens will not be used as collateralized dependent tokens. The supply and demand for collateral and dependent tokens, such as the FXRP system, would be distorted were the foundation to deploy its collateral into these applications. No Oracle participation. It is desirable that over time, the foundation reduces in importance relative to other participants. The large initial token holding combined with sensible financial management should suffice. Providing the networks gain tractions to make sure that the foundation is capable of discharging its mandate for a sufficiently long period, such that at the end of the period, the foundation is no longer needed. The foundation will participate in the FTSO. In effect, the FTSO award rate then becomes a measure of the speed with which the foundation percentage ownership decreases relative to the collective ownership of other participants. This does not mean that the foundation's net worth will necessarily reduce in parallel, as a Spark token value may change and/or investments using a Spark token could yield positive returns. The right to dissolve. The network has the right to dissolve the foundation if desired. This is achieved by enshrining in the bylaws of foundation legal structure a stipulation that it must be disbanded if the network votes to do so. It is highly likely that upon such a vote, it would be impractical or impossible for the foundation to dissolve immediately. However, the foundation will submit a plan within 60 days to wind down operations, liquidate assets, and burn its remaining token holdings. Any non-Spark assets will be used to purchase Spark tokens, which will then be burned. And lastly, reporting. Transparency is key, for the Foundation will issue a report every 6 months detailing sales of Spark tokens, employee remuneration, expenses, and other use of funds, investments, and grants. If you made it to the end of the video, thank you so much for watching. If you enjoyed the video, leave a like and subscribe. Also, if you would like to stay up to date on our educational content, we will be posting daily on the channel. Also, click the bell notifications, comment if you would like to see more of specific content ideas, and remember, you can stay connected with us via Twitter at Delgado Crypto. Again, thank you so much for watching. I hope to see you there.